Unity, so we'll be talking on materials, lighting, and other things. So firstly, let's talk about materials. So previously in our other days, you saw how to add color to any object. So what we did is, let's say we created a plane. Let me increase the size. So let's say this was our plane, and the way we added color to it is we created a material for it and changed the color. So let's create a folder called materials. And then the material folder, let's create a material, simple material. So if I apply this material on this plane and then change the color albedo of the material, the color of the plane changes. So this is how we change the color of any object. But as you can see, this is not always enough. I mean, things like wood and some other objects in real life, they don't have a single color. They have like a texture to them, and we can achieve that kind of effect by using a texture. So we will be covering that in some time. Right now, I want to show what else we can do with this material. So first of all, the first line in the material is about is something called a shader. So a shader is a program which tells the computer how to display an object. So for now we are using a standard shader. Standard shader is a built-in shader made by Unity, and it comes built-in. And any object you make or any material by default takes the standard shader. There are other types of shader, but right now and also most of the time you don't need to use them. Like 90% of the time, anything you want will be done by the standard shader. So now let's come to the rendering mode. So right now it has taken the value opaque. So opaque means that the object is opaque. It is not transparent or translucent. So if we want to make our plane transparent, we can set this to transparent. And you can see even now it is still okay. That is because we need to set the amount of transparency using the albedo. So if I select the albedo again, and in this alpha channel, if I reduce this, then you can see the plane is becoming transparent. If I put this to 0, the plane will become totally transparent. And if I increase it, it will become less transparent. So that's how you achieve transparency. So if you want to make windows or glass, you can use this. Other than that, as you know, this is the albedo. So this is how we set the color. And let me just reset it back to opaque. Then there is the metallic, which tells how metallic is an object. So metals behave differently with light as compared to non-metals. So that is how we set how metallic a material is. The smoothness tells how smooth the object is. So things like glass is very smooth, while ground and dirt is very less smooth. Other than that, there are these normal math, high math, occlusion, and detail masks. These are something which we'll cover today in some time. Now, after that, there's the emission. So, emission, what this does is, if you set this to true, then you get this one, this part. And in the color, if I set this to something other than black, you can see the object will take a color similar to that. It's basically the object is emitting light of this particular color. Now, how is this useful? Well, if you maybe want to create some kinds of light, like a neon effect, you can use this. So, the thing about this is, since the object is emitting its own light, it does not need any external light source to be illuminated. So, this is how you can make an object which is glowing or something like that. So, that is how emission is used. Tiling and offset are used to adjust how the material is tiled. So, for example, if you have a texture and you want to, well, I think this should be covered later, but right now, I just want to tell that if you have a texture, if you want to increase the size of the texture as compared to the object, you can set it from here. And then there are these secondary maps. Most of the time, you will not have to use all of this. So right now, we are skipping this. Now, as I said, by only setting the color, it is almost impossible to achieve a realistic look. So what can we do about that? So this is where some of these maps comes in. So first of all, I told you to download that example folder, and if you open that example folder, yeah, so you get these two files, example scene and textures. If you go into textures, there are these two folders. So let's just select both of them, drag it into Unity, put them in the materials folder. The Unity will import both of them. Okay, now we have two folders. And let's go into the first folder called the classified Cobble Unity. Okay, so you will see that there are a number of images in this. What this is it's basically a texture of an object of a stone, cobblestone, and if we use all of these, our objects will look something like this. So if you open this circular image, this is basically a preview of how it will look if we use this. So as you can see, this material has a lot more detail. It looks a lot more realistic, and we can achieve same kind of realism in Unity as well. So how we do this? So first of all, let's go back into the material folder, create another material, give it cobble. Let's apply this on our plane. Now let's go back to the rough weight cobble folder. And okay, let's select the plane, go to its material, and this is the material of this plane. Now, so the first thing that we have is this one. So this is basically an image, is this file. So it's called rough weight cobble albedo. So as the name suggests, this is the albedo of our of our object. So earlier we used to set the same albedo, same color for the entire object. Now we can give it an image and it will just paste this image onto the object. So as you can see, it's basically a picture of how the surface should appear. So let's drag this into, okay, so let's select the plane, go to the material again, and drag this albedo file into this little square that we have next to the albedo. If we do that, as you can see, the material now, the object has taken a color similar to that, as if a picture has been pasted on it. And it looks somewhat realistic, but not really enough. I mean, it's fine, but it's not that great. So how can we improve this? So for that, we have these other maps. So firstly, the most important one is called this one. So let me open this. It's called rough weight cobble normal. So this is a normal map. A normal map basically shows information about the geometry of the object. So it's basically it shows the normal vectors of the surface of the object. So and the vector, as you know, vectors have three components, x, y, z. Those x, y, z are stored as RGB values of the image. That's why at some places this image is red, somewhere it is blue, other it is green. So red, all that means is at that point. So for these red points, the red channel is of a high value. That means one of the x, y, or z coordinates of this point is of a high value. So you don't need to know all of this. You just need to know how to use this. Now let's again select the plane. Drag this normal map in here. Now, as you can see, the plane looks much different now. Also, there's this fix now button. What this says is the texture is not marked as a normal map. Basically, you need to tell Unity that you're importing a normal map. And Unity gives you a warning if you're not let to do that. Yes. So,
Can you please remove the normal map and again insert it?
okay, sure. And if I reinsert it, it looks different, as if light is behaving differently with the.
Yes, yeah, got it.
Yeah. So if I press fix now, it will look slightly more different. Basically, Unity now knows that this is a normal map and uses it slightly differently. Yeah. So you can see, it appears that the object has become 3D, but actually it is still a plane. It's just an illusion which is being created by the use of light. Basically, using as I said, the normal map shows the normals or normals of the surface. So using those normals, Unity calculate lighting differently, and so some places are shaded black while others are made white. So as to give effect of shadows and highlights. Now the next thing here is the height map. So height map is again similar to normal map, and it actually it is but what it does is gives an effect that is as if the object is actually raised up or down. So let me select the height map. So if I open the height map, this basically look like the surface just in black and white, and the white portions are which are more higher and black portions are lower. So if I apply this, now that 3D effect is even more pronounced. I can set how much effect I want using the slider. So if I set this to 0, there's barely any effect. If I set this higher, you can see there's more 3D effect. And if you move the slider, you can see the object being raised up or down. So let me set this to the highest value right now. And again, actually the plane is not actually raised or lowered. It's just a effect or an illusion that is being created to give this effect. In more advanced systems or more like high-end systems, you can actually change the height, actual height and the of the plane, but usually that is not done to um, save up processor space. I mean processing power and all. Now, yeah. So the next part here is the occlusion map. So this is the occlusion map. And what the occlusion map does is it stores which part of the image have more shadow and which do not. So if we apply this occlusion map, okay, so sometimes the effect does not come. You need to, okay, so yeah, so sometimes the effect does not directly come after applying the occlusion map. You need to go to Windows, rendering, light setting. And I actually like to drop this light setting in here. And you go to real time global illumination and switch it on, and you generate lighting. Okay, so there's slight change in the lighting. It has become more black, right? But other than that, it is still the same. And the effect of the occlusion map should be visible, I think. Okay, it's still not very visible. I'm not sure what the reason. Okay, yeah, it is visible. If you look closely, and if I reduce this, you can see that the central part becomes slightly brighter if I set this to 0. But if I set this to 1, the central part becomes darker. And that is the effect of this occlusion map. It is not that much pronounced on this particular material, but in some materials, the occlusion map plays a very big role. Now, the next thing is this metallic part. So right now, the entire surface is of the same metallicness or smoothness. So we actually change that using a metallic map. So let's select this. I'm sorry, that opens up in Photoshop actually. And right now it just appears black, but actually it has information stored in it. So let's select the plane. And let's select the metallic map. Oh, sorry. But this is the metallic part. And now you can see the stone part is now appears rough and less smooth, while this crevices in here appear as more shiny because as if there's water in them. So you can see the effect here. This part appears a lot more shiny as if there's water in that, but this part appears much more rough. So this is the effect of the metallic map. I'm sorry. Yeah. So this is how all of these things work. Detail mask is actually you don't usually use this. This is for some other specific purposes, but you don't need to know about that. Yeah. So this is how it works, the basic system. And as you can see right now, it looks really much more realistic than what we had earlier. So this is one of the materials. Now let's create another material.
Do you have a source for these material
Yeah.
maps?
Yeah, so basically, you just need to make a Google search of Unity PBR materials, and you can find them on the asset store. There are a lot of materials on the asset store. There is also a website called Free PBR where you can download all of this. So most of them, a lot of them are free, not most of them, a lot of them, and you should be able to do most of the things you want with just free materials. So just make a Google search and you'll find most of it. Yeah, so let's make this second one and call this pool. Let's apply this plane. Let's open this second folder which we imported called title pool. Okay. And this time I'm just not going to explain everything. Just put everything in there in the so put the LVO in the LVO channel. So put the aim at occlusion map in the occlusion channel. I think this is the height map. Yes. So put it in the height map channel. Put the normal map in the normal map channel. Fix now. And yeah, this should be the metallic map. Yeah, so as you can see, this same plane, the entire plane is using the same material, but different parts of it appear different. So yeah, so this part appears as if there's water. This part appears like a land part. So as you can see, this using these materials, you can get very nice effects, very realistic effects. And usually, this is how you get realistic effects in your game. So you can find materials about of almost everything. You can get wood, and glass, and everything. Almost every surface, every type of material, you can get a material of it on. As I said, just go to freepbr.com. That's a very good website. Or go to the Unity Asset Store, or make a simple Google search about Unity materials, and you will find most of this. So this was about material, and if you know this much, you should be able to get most of the stuff done. Now, next thing I want to cover is lights and lighting. So first of all, let's cover lights. So in the default scene, when you open it up, there's this directional light already present. So what is the directional light? Is it's basically gives the direction from which light will come. So uh, you can move this anywhere you want, and the lighting will remain same, because the only thing which this directional light cares about is the rotation. So if I change the y value, you can see the light is rotating. I can change the x or y, and that will change the position of the light and the position of the light here. So this is what a directional light does. Directional lights are usually used to create the main light of a scene. So usually for sun, if you want to create a sun, if it's an outdoor scene of morning, can be used to create the moon. In indoor scenes, usually it is not used, but you can still use it sometimes. Now, another type of light is the point light. So let's create a point light. So here we have the point light created. Let's reset its transform. So now the point light is positioned here. So as the name suggests, it's a point from which the light is emitted. So the position does make a difference here, because as you can tell, the position tells from which point the light is coming. And if I increase the intensity, you can see that particular part is becoming brighter, because that light is affecting it. The circle around the light is the radius of how far the light will go. If I increase the radius, you can see the light is going much further. So point lights are very, very useful. They are mostly used to create lamps and other kind of things. And yeah, so this is the use of point lights. Now the last kind of light is a spotlight. Yeah, so let's create a spotlight. I create a spotlight. Let's reset its transform. And I'm going to just disable the spotlight for now, just to demonstrate the spotlight. Let's go to the spotlight. So as you can see, it's like a cone is coming out of the light, of the center of the light. So as you can imagine, a spotlight is like it's just a spotlight, right? So it is like a torch. So let's rotate it first of all along the x-axis by 90 degrees. So it faces down. Now if I increase the intensity, as you can see, that particular spot is getting illuminated. If I increase the radius, wider spot will get eliminated. So I mean, it's pretty self-explanatory that what the spotlight does. It's uh, it's very useful when you want to create a torch, or maybe like a street light which is facing downward. But usually spotlights are not that useful. But still, if you can find a use for it, use it. So yeah, so that this covers how to use lights. What are the different types of lights are. Also, if also let's just go through these settings which we have in the light. So the directional light again. So the first setting that you have in a light is its type. So from here also you can change if it will be a spotlight, it will be directional, or it will be a point light. So let's just set back to directional. Also, there's a type called area light, but that's slightly advanced topic, because it uses big illumination, and we are not covering that part. So let's not cover it. Yeah. So the second thing is the color. So yeah, so basically I am very self-explanatory. Just the color of the light. So if I want a more blue light, I can set this to blue, and yeah, the same thing. I can set this to white. Now, those is mode. So again, I would rather not explain this in detail, but just think about this. If you open this, it says real time and baked. So real time is when Unity calculates the lighting in real time. As the game is running, the lighting is being calculated. The baked part is when lighting data is already stored, and during when the game is running, the lighting is not calculated in real time, but it looks up the stored data and uses it. So you don't need to get into depth of these two. Just set it to mixed, and there'll be no problems. Yeah, the intensity is again pretty self-explanatory. You just set how intense the light is. And the indirect multiplier is here. So as you know, light does not stay. So for example, when a light falls on any surface, it bounces. So in older game, these bounces were not simulated, and that actually those bounces are very important to give a realistic look. So this indirect multiplier is how you adjust how much that bounce of light is calculated. So if I increase this, it usually does not have any effect in directly. Yes, because it uses mostly uses wave lighting. And again, that is slightly advanced topic, so I don't want to go into that. So most of the time you will not have to use indirect lighting. Just use a simple set intensity to set how bright you want your scene to be. Yeah. So the next part is the shadow type. So soft shadow is whenever you will have an object in the front of the light, the shadows will not be hard. So let me try to give an example. If I get this too hard, right? Let me see. Let me create a cube. Yeah, so as you can see, the cube has a shadow on the surface right now. If I select the directional light again and set this to hard shadow, you can see this shadow has become a lot more pronounced. Like it's almost like a cube. It is a huge shadow of a cube, and it is like very hard. The corners are very sharp. But if you set this to soft shadow, oh, I'm sorry. Yeah, so this is soft shadows. The corners become much smoother. So actually, this is just a part of realism. So in real life, the shadows are soft. So you can use the soft shadows. But if you want to go with an effect, different type of effect, you can use a hard shadow. All of these settings are used to control. Yes.
Those short shadows use more of the GPU. So
Yeah, that's true.
yeah.
So yeah, if you are using a lot of lights, if you're not using too many lights, this should not have any big impact. But if you're using a lot of lights and all of them are using soft shadows, then it will of course have an impact on the performance. So keep that in mind.
Okay.
Yeah, and after that, these part is again not very relevant. So let's skip that. So yeah, so this was the part about lighting. This is how lighting works in Unity. How lights work. Now let's go to the lighting part, which is basically so this was about individual light. How do we light up a whole scene? We need to use a combination of different type of light. So let's talk about that. So to do that, go back to that folder which you downloaded, and in there, this is this example scene. Double click it, and Unity will start to import that scene. So just click on import, and it will take a yeah, it's done already. Yeah, so you'll see in your Explorer, in your asset folder, that there's a new folder called Colonial Graveyard. This is basically a asset which I downloaded from the asset store just to showcase how lighting works. Now, if I go to the scenes folder, there's this scene. Let's double click it to open it. I'm just saving the settings in my current scene. If I want to go to the next scene, so let me just click save, and this should yeah, there it is. This is the new scene. This is the graveyard scene. So as you can see, this is a graveyard, and this building, probably a church or something. And as you can see, it is being illuminated. Currently, there is this directional light which is acting as the light source. So if I set the intensity of this directional light to 0, you can see the scene is still lit. What I mean, if this was the only light source, and if I set its intensity to 0, then it should have become totally dark, but it hasn't. And that is because if you go to the lighting, yeah, by the way, if you want to get this lighting tab, just go to Window, Rendering, and Lighting Settings. Yeah. So right now, if you go to Lighting and go to the scene, there is this in the environment lighting, there is a source called Skybox and an intensity multiplier, which is right now set to 1. Basically, what is happening is if you look up, Unity provides this default Skybox. This is basically it is basically sky, and what this does is it gives its own light to the scene. So basically, you can see the slight blue tinted light. That is because the sky is blue. That's why the entire scene is getting slightly blue due to the light from the sky. So if you want to change that, if you don't want this skylight, you can set the same intensity to 0. And now, as you can see, this entire scene is gone black. as if there is no light, because there is no light right now. Another thing, so if you are doing a nighttime scene or an indoor scene, then there will be very little or no light from the sky. But if you are doing an outdoor scene, then of course the sky provides a lot of light. So keep that in mind while building your scenes. Now, so yeah, so let me just set this to a value of 1. Yeah, so another very interesting thing to note is that in our skybox, if we, sorry, okay, wait, it's not visible right now. Let me just see. Okay, so I'm not actually sure why it's not visible, but by default, this default skybox has a sun in it, which basically follows your main directional light. So if you move this directional light, if you change the angle of it, the sun basically follows it in the sky as if they to give an effect as if this directional light is that sun. But right now it's not appearing to do some reason. I'm not sure. So let's move ahead. Yeah. So this is the skybox. This is what the skybox does, and now the next thing, if you look in the sky, it's very simple right now. I mean, there's nothing interesting. There are no clouds or anything. So what if we want clouds? So to do that, go to the go to this folder called Colonial Radar, and in there is this skybox folder. In that folder, go to materials. And you will see these two images. Just try to select one of them. Go to the inspector, and you will see something like a clouded sky in it. So basically, this is a 360 image of a 360-degree image of a sky, and we can use this image to give to add clouds and to our scene, to our sky. So how do we do that? Let's go to the lighting again, and in the skybox material, you can see it is using a default skybox. So as I said, Unity comes with a default skybox which looks like this, and if you want to change that, we can just drag this in, drop it in here. So now you can see it is changed to skybox daytime, and these clouds have appeared in the sky. So this is how you add clouds to your scene. Now there's this another skybox. If I drag this, it you get a effect of evening. It's night time, but I have set the day and night cycle. It would lag a bit since I'm running this on Unity, but when I get the actual project, currently it's in the drone view. When I press F, it would come to the FPS view. So these are the trees. You can just notice the subtle wind effect on the trees. You can see the trees moving. Get a bit lower. Yeah, and this was the lake that I was talking about. Let me jump to the ground. This is what you can do with the terrains. All the part that that Shivam taught just now and my part are both included in this. And this file has been created using the particle system as well as those lights. They have set the time of the day to a bit slow, so you have to wait for some time to actually see the sunrise. Really sorry for that. We'll change it. So till then we can relax in. Or we can go to the drone view again. This is basically the moon lighting. You can adjust intensity as well. So the skybox that Shivam told you, go there too. Also, I have added the fog effect that is included in the lighting settings. So the basically what is happening is that when it's the daytime, the fogs are whitish in color, and when it turns night, the fog turns black, so that we don't get a ghostly effect, which should happen at the time of sunrise, the skybox color is changing. Like you can observe, not exactly realistic, but I guess bit better. This would be the good view. Where is the sun then? So on a lighter note, the only way I can see sunrise nowadays is in this game, because I generally wake up in the afternoon. So probably that one of you were asking the doubt that what happens if we change the color of the directional light. So you see only the shadows are getting it. Like you can see the trees, they are a tint, but there is not much effect with the sky. So yeah, let's continue. So we were talking about the skybox, and we added this sunset skybox, and it gave an effect of evening sky. Yeah, so this is how we use skybox. Let's just set back the original skybox, the daytime skybox, so that we get the sky. Now, what I want to talk about right now uh, is how to light up this scene. How would you light up this scene? So, as I said, this intensity is very useful. I mean, if you have a daytime scene, because in daytime the light actually comes from multiple directions because the skies are also very bright. So this you can use this intensity to give that effect. While at night time, there's no such light from the sky. So at that time, it's better to set this to zero. Also for indoor scene, again there is no sky light from the sky. So again set this to zero if you are having an indoor scene. Um, yeah, and after that, for an outdoor scene, usually we use a directional light to create the sun, and then from there on, we add smaller lights at various other places wherever we want. Uh, so this is how we mainly light up our scene. Now I want to talk about things like post processing and other graphical aspects of a game. So, post processing, as the name suggests, is something you do in post. So, basically, once a scene has been rendered by the computer, you add post processing to it to enhance the graphic quality or the fidelity of the scene. So, so we'll talk about post processing. Before that, I want to tell a few more things. So, if you want to edit, you go to project setting, and then you can go to players, and in there you can see this rendering color space, and it is right now set to gamma. If I set this to linear, Unity will re-import all of the assets. Usually takes around a minute. I'm not sure if it's visible to you or if you're able to see it, but the lighting actually changes a bit if you use linear. And actually, linear is considered the better way of lighting, but there's also gamma. Almost all of the time, linear is used. I have never seen gamma being used, but I still don't know why Unity comes with gamma as default. So, whenever you are creating a scene, just set this to linear, and almost all the time you will get better graphic quality. So let's close this project setting. Let's go to the main camera, the inspector. In here, in the rendering path, set this to deferred. So usually this has very small effect, but this is usually done if you have a lot of lights in your scene, so you want to use deferred lighting. I think, as far as I know, forward is used for lower end systems, but most of the time, if it's a decent system, you use deferred. Also, this HDR and MSAA are controlled by the graphic settings. So let's just see if they are enabled or not. So let's go to edit. let's go to project setting. Let's go to quality. Okay, let's go to that.
Can you pause 3 seconds because it lags?
Oh, I'm sorry. Can you see the screen now?
Yes, yes. Thank you.
Yeah. So we can see that use HDR is enabled. So that means that our scene is using HDR for. So HDR is basically it's actually very difficult to explain, but what it increases the color space so as to include more colors. So it's actually a very popular term. So basically you almost always want to use HDR because it gives better graphics quality. It allows your game to use more colors, more number of colors. So just check if you have HDR enabled and enable it if it's not. Now let's exit this. So yeah, so what we have done till now is we uh, set the rendering part to default. We checked if the HDR is on or not, and also we set the color space to linear from gamma. So these are a few small settings you do to which give small to medium improvements to your game. Now